So we've had a board come in. It was pronounced dead. So you'd instantly think, let's try the voltage regulator. Measuring the voltage regulator, dead. Well, the next port of call you would probably imagine replace voltage regulator. We looked at the ISO driver and found it to be bad, so that was changed. When sending the wake up command, it still wouldn't wake up. But we did have 5 volts, so that showed that that was interfering. So after testing the wires, I found 2 of these very, very small wires under the chip were showing resistance. So we've lifted the chip, we've repaired the 2 wires, replaced the chip, replaced with a new chip, various soldering around the op amp. This area generally on these Hella boards, it's always bad here. A few touch-ups on the back. Capacitors came out, with the capacitance was tested, they were fine, no signs of leaking, they've been put back in. Then we acquired a wake up command and it woke up, and it was showing that the room was 38 degrees, 39 degrees, 40 degrees, and it just kept drifting up and up and up. So we changed the temperature sensor, and now the room's at a nice 24 degrees, which it probably is. We've used marine grade electronics, well actually it's a mil spec, so it's a military specification grade silicon, electronic silicon, neutral pure. Problem with some of the first Webasto boards, not so much these Hella, but the actual Webasto boards, when they were mounting the components they used a white silicon, and that was the acid cure silicon. That's the silicon that you would like associate a vinegary smell with, and of course that being an acid eats and attacks the board, so the actual manufacturer used the complete wrong grade of product. Obviously other areas are touched. The MOSFETs, they've now got the correct amount of solder on, high side switch. Then the board's been retopicalized, properly topicalized as well. So as you can see the split line there, that's just where we dip. See that on the back as well. All the boards we do are given a number. This one's 125. This is so we can trace it back for traceability purposes. And so I can say 125, I don't want to see you ever again. So we'll get this soldered back into its cradle. We'll finish the topicalization layer, and then we'll do some testing. So all these parts have already been ultrasonically cleaned. The pins have been retinned. It's good to go. And when you got stuff right, just goes like that. You can't do this without hot air and you know, you've got this big cumbersome soldering iron, forget it. If you're using flux from Halfords or solder from Halfords, forget it. This is hard lead-free board that requires leaded solder for repair. It's the only thing that stands up to the vibrations and the changes of heat. This is why the board's here in the first place. Whoever said lead-free solder is good is crazy. You know, temperature controlled iron. It's not an expensive iron. I don't believe, you know, we're professionals. We don't use anything like a big Heiko station. We don't need it. Because when you've got your chemistry just right, and the trick is expensive solder. This is Kester 44. It's 180 degree solder, so not a high temperature solder. High enough, but should this board need removing from the cradle again, it won't be the drama it was when we first saw it. There you go, big ground plane on that one. Just going to apply a bit more flux. Okay, just a quick zizz under the microscope. Okay, they all look great, they just need cleaning now. Let's see if I can get you a bit of a closer. So we'll clean them up. And this is what your joint should look like. I know this is terrible, we haven't got a camera for the microscope yet, but nice, shiny, clean joints. Nice big fillets in the resistors so they don't want to drop off. So that's all good. So we'll apply the topicalization. Webasto also use some sort of cellulose-based gunge that they put on their boards. We don't do any of that nonsense. So where that line was left from the coating, I'm just going to recoat that manually with a nice amount on the cotton bud. This stuff's far superior to Webasto's conformal coating. That's good. Bring in the secret device. So you can see that now we've topicalized the line manually. Okay, so what we're going to do is bring in the magic device. Oh, it's making the camera go a bit weird. Just using the UV to. This is a cheap woman's UV nail light. Works absolutely perfect for setting our conformal coating. Okay, so we'll give that the other 20 seconds it needs, and then we'll set it up on the computer and give it a full test. There we are, we've pretty much finished the testing now. It's all good. We have the adapter connected. Pin 6, the fuel pump, which is the last one to test. So I thought I'd shorten the video because it's quite boring. So you see, pin 6 connects to an LED, to a resistor, to ground. Now, it's on. But it's only on a little bit. Because what that is the Webasto checking the circuit. So we're on component test, fuel pump, we'll press start, and you'll watch the LED properly. So that's what I was doing now, is it's sending a current through to see if the pump's there. So now we'll start the fuel pump. There we go. quite nicely. There it stops. And that concludes the end of the test. So this will now get packed away. And ready to be shipped first thing in the morning. So once they're done, they go into their own graphene painted shipping cases for their protection. That now gets posted. Yeah, for doing this video, one of the major reasons was to promote the website. It's come a time where we have to stop selling on eBay. The fees and seller fees and PayPal fees and fees on fees just don't make it feasible. So from now on, all business will be conducted through the website, as should be. Now, Robinson Labs is looking for 5 people. 5 people who have A, a spare thermotop C, B, time on their hands, and C, know a little bit about how these heaters should work and a little bit about programming. If you have that skill set, then these will be available shortly. There will only be 5. So we want 5 people to work with us in their own time to produce better firmware, so that once we have a solid firmware, we'll go into production with these, and then this will be a fully drop-in replacement for a damaged non-working PCB. However, not yet. This is only at experimental stage. So here it is. The best looking thermotop C board there is. We have an IRLB 3034 PBF for the glow plug. It's capable of 195 amps package capability, silicon capability 343 amps, so it'll destroy your Webasto before you destroy it. The rest of the work is carried out with the IRLR 7843. These packages here, they're also capable of 90 amps, so yeah. 18 mega 328, 16 megahertz for full tolerance. Programming header. Oh, there we go, that's better. Programming header. with 3 temperature sensors, 2 10K thermistors, and the one TMP36, which isn't programmed but can be. Some bicolor LED lights for status, a manual switch which can be programmed to turn on or for testing purposes. We broke out PC3, broke out TX and RX. That's another like jumper for switch. Anybody's interested? Email robinsonlabslimited@gmail.com. I'm going to work with this project over the next 3 to 6 months, and once complete, this will be a drop-in complete replacement, good to go. Shipping has got back to some form of normality. However, we are still waiting for orders from the 6th of March. Whether they ever turn up, we have quite some capital tied up in these things. Yeah, controllers, they will be soon, at least by winter anyway. That's that worst case scenario.